For this multiple LED project, what I'm going to do is show you how to read a schematic as well as how to do some soldering. So the first thing I want to do is go through with you and show you that you should have a little green board, printed circuit board, as well as the schematic. I sent the schematic to you by email. Now, I know that we do have a little bit of a dilemma with the capacitors, but if you maneuver them around, hopefully they'll be okay. Now, if I did give you the wrong capacitors, and I'll go through that a little later on, please let me know and I will send these out to you and we can get those exchanged out. For now, what I want to do is look at this schematic and try to identify the different various components we have here. So, as you can tell, down here we have diodes. You notice the diode itself has a unidirectional, That means it goes on only one direction. So this line right here is the cathode, and down here is the anode section. So the cathode's up here, the anode's down here. It is important that you put these diodes correctly in the board, and I'll show you and demonstrate that to you shortly. We have a 9-volt battery with the leads that will come out of it. You have a 555 timer chip, and yes, you have to put this in correctly. Pin 1 is always going to be with the dot on the board, and there's like a little indentation. I'll show you again what that would look like. The 2N222 is a transistor, and we are using a 2N222A. There is a difference in packaging, but they both work the same. And then you have the LEDs. LEDs have polarity. On our LEDs, you'll have a small lead, that's your cathode, and the long lead is your anode. So we have 3 LEDs. And then we also have 800 ohm resistors up here. Now you're thinking to yourself, why do we have 800 ohms? Well, if we have a 9-volt battery and 800 ohms, that brings the current down just right into spec for those LEDs. Remember, LED works between about 15 mils to about 20 mils. So with that said, what I'm going to do now is switch over to the document camera, and I'm going to show you how to test the board to make sure all this is correct up here. So please have the schematic in front of you, and we'll begin very shortly. So the first thing I want to do is find the emitter on this T2. So looking at the data sheet, I notice that it states that emitter is pin 3. So since I do not have these marked, what I'm going to do is find out which one's pin 3. I do believe this one is pin 3, and it is because you hear the beeps. So that means this is pin 2, that's the base, and this must be the collector. With that said, I'm going to look back at the schematic, and I'm going to see that the schematic states that the collectors are connected to my cathodes, and so that's important. So we could do that. Let's go back and actually check that for all these LEDs. So my cathodes should be connected to my collector. So let's look back at that. So my collector, I do believe, is this one right here, and I can check, and it should be, yep, there it is. There it is. So that's my collector. So that means these are going to be my grounds right here. These are going to be the short leads. This is where the short leads are going to go on for my components. So I'm checking different stuff right now, as you can see. So the next thing I want to do is check to see if these guys are connected up to the 5 volts, or the 9 volts. And they are. So that's looking good. Next thing I want to do is check this IC right here. Since if you look at this indentation right here, this indentation is pointing toward the front of the chip, and this dot points to pin 1. So in order to understand what we have here, I'm going to do is check to see if this is actually set up correctly. And I know pin 4 should be a high because that's reset. So it's 1, 2, 3, 4, and then pin 8. So those are good. And then I'm going to check ground. See, and it should be pin 1. That's good. So this looks like it's all set up correctly. So I think we are ready to go. The other thing I want you to point out to you is that you notice these diodes, D2 and D1. You notice that they have a band right here. Well, there is a band on these diodes right here, and I'm going to try to bring this up, and you see the little black. You see that little black line on the diode right there. Well, that little black line on the diode belongs with the board over here, so we have to align those correctly. So the first thing I want to do is I want to bend these leads right here and make it straighten them out a little bit. So you might have some leads that are not straight. So what you do is you take the lead and you put it in here. And then what you're going to do is give it just a little bit of a tug on the pliers, just like that. I'm going to get this out of the way so you can see it so it's a little better. Now what I want to do is give this a little bend. So I just give it a little bend, just like that. And then I give another bend on this side. And what I'm doing is not putting, the reason I like to do these bends is that I'm not putting stress on the semiconductor device. Remember, this is a semiconductor device, and these leads actually go in here. So we want to try to keep the pressure off the semiconductor device. Now, since this is the component side, because it has the silk screen with all the parts on it, the diodes D1 and D2, so I'm going to find D1 and D2, and I can start with whichever one I wanted. You notice that I have the band right here, and I notice that the band is over here. So what I'm going to do is stick this right into here, just like that. Give it a little push in. Sometimes it takes a little bit of fingernails. And then on the back side, what I do is I bend these leads over, just like that, so it holds it in place. Just like that. So this right here is the chip holder that I gave you. It's an 8-pin chip holder. It does not have any polarity to it right now. We don't care about polarity. What's nice about these chip holders is that we can put these in and not damage our chip. So we can actually, if we have a bad chip, we can actually remove the chip very easily. So let me show you how to put this in. So this gets a little tricky. Sometimes you have ones that look like this where it's a little more cheaper and it's flimsier. The ones I gave you are much better. They're easy to put in, so you should have no difficulty. You usually don't have to bend the pins around for those things. So you just slip it in. This one actually worked pretty well. Again, what I'm going to do is remove my clips from my helping hand. Yes, this is called a helping hand. And on the back side, what I'm going to do is bend these leads over, and if you needed to, you can. Now on yours, you're not going to be able to do that because of the style I gave you, because they're really stiff, and that was the intention of it being stiff, so you don't have to bend those leads over, and it should stay right in place. If it doesn't, I'll show you a way to actually get around that too. So here's the leads. They're bent over. I'm going to try to increase the view of this. There we go. As you can see, I bent the leads over, and they're now nice and snug in the holes. So all I'm going to do is switch back over to my other side, and I'm going to go ahead and put in some LEDs here next. I'm going to put in some LEDs next. Fix them. There we go. So on an LED, you actually have a long side, the anode, and the short side, the cathode. So in this case, we already found that our cathodes point toward the transistor, and we know that because we tested it. In this case, what we have is the cathodes are over here, and it's going to point toward the transistor. So what I'm going to do is take this LED right here, and I'm going to go ahead and insert it into here, just like that. Now, you could bring it off the board a little bit if you want, but I like to have it flush on the board. I know these are a little tight, so you may have to snug them in there a little bit. And do that for LED 2 and 4 also. Do it for LED 2 and 4. Next step I want to do is actually put the resistors in. Now, since you already went through my DC course, remember you could use your multimeter to see what the value of these resistors are. Or you could do is look at the banding on it. So if you look at this, if we were to put in these resistors right here, this R5, 4, and 2, what we want to do is those have to be 820 ohms. That's based on our schematic, and if you're not sure, you can look back at your schematic. So if we look back at our schematic, those are 800 ohms, 820 ohms. That's perfectly fine. That works for me. Now, resistors do not have polarity, so what we do is just go ahead and insert these into the board. So I like to bend the leads like I did before, and sometimes they need to be a little bit adjusted. That's fine. So you just readjust. If it doesn't go in right, you just do readjust it. That's all. There is some tools they have out there that would help you with the positioning of this. We do have them at the college as well too. So it's all up to you. Some people prefer not to use them. Some people do. In industry, what we use is a machine to put all these components in. We don't do it by hand. So unless you're prototyping, and then usually a prototyping, what you'll do is have a engineer, technician, or similar that would be putting those components in. So that one did not go in correct. That one went all right. That's okay. I'm just doing this as a demo board here. There we go. So there's that. There's 820 ohms. So I'm going to do the transistor with you next, and from there we should be able to start. I'll pull up the board I already put together, and we can actually start. So on this transistor, you're going to notice that you'll have a little notch on here, on this. I don't know if you can see that notch too well, but there is a notch on here. There it is. That shows up better. This pliers is pointing to that notch. This is going to be pin 3. Pin 1 is in the middle, and then pin 2 is the end. So pin 2 is going to be your collector. Pin 3 is my pliers, which is going to be in the emitter. And pin 1 in the middle is my base. So what I want to do is I just inserted this transistor into the circuit. You notice my little lead right here is actually pointing toward my left, and it's pointing toward the chip holder here. Because we tested this, and this means that this should be the emitter, that should be the base, and that should be the collector. So if this is the emitter and that's the base, if I take my meter leads and I connect up my black lead to the emitter and my red lead to the base, I should get about 0.6. And remember, you have to set your multimeter to diode setting. In this case, I do. Likewise, if I take my leads and I stay on the base, my red lead on the base, and the collector on the black lead on my collector, I should get about 0.6, and I do. Why is that? Because this is an NPN transistor. That means that this is what I call negative, positive, negative. That's how you tell. Now remember that I tested already, and I could do this again. This should be my emitter. My emitter should go to ground. And it does. You can hear the beep. So I think that's incorrect. I do believe it is incorrect. So if I test this part right here, this should go up to that, and it is. So this transistor is incorrect. It is correct. So prior to soldering, what I want to do is demonstrate to you how to solder. So the first thing you want to do is make sure that your tip, and let's see if I can focus this in, is nice and shiny. I'm having a little hard time doing that because I'm bouncing around here. I'm going to bring it out just a little bit. Maybe this will help it out just a teeny bit here. So my tip is pretty much shiny. It has a little bit of residue on it, so I'm going to go ahead and clean it. Just give it a clean with the sponge. Remember, my sponge has to be sopping wet. Sopping wet. And then I'm going to go ahead. I got some tinning solution here. I'm going to retint it, see if it looks any better. That looks much better. Nice and shiny. So I'm going to go ahead and I'm going to bring this in to show you how to solder. I'm just going to do a couple demos on this board here. This is called demo board. So I'm going to do is refocus this in. There we go. So what I'm going to do is you want to apply the solder to one side and heat to the other. My irons are about 330 degrees Celsius, and if it needs to go up a little more, we can. But right now, I'm going to try to do is just get this thing soldered in. So what I'm going to do is put my lead right there. Count to 3. 1, 2, 3. Boom. It is done. I think that is done. Take a look at that. That is done. So for soldering, what we want to do is, number one, make sure our tip, and I'm going to do is bring this out. I'm going to try my best to get this thing focused in. We want a nice shiny tip. So I'm going to see if I can get this to focus in. And you see it's dirty. So what we're going to do is give it a nice clean with the sponge. First of all, remember your sponge has to be sopping wet. And then I have some tinning, so tinning stuff. Looks gross, but it's actually pretty good. And that's why I call my tinning solution for my thing. And then I just give it a quick dab. Remember, anytime you use a sponge with water, remember your temperature drops off on your iron. So, and what I'm looking for is that. Perfect. Second thing I want to do is when I start soldering is to make sure that my board is clean. And usually when you're dealing with boards that are dirty, you use flux. Flux is a cleaner. And in this case, I have my solder itself. And I'm not going to, because I know these boards are pretty clean, so I'm not too worried about dirtiness. But always just make sure your board is clean. And if you need to, wipe it down a little bit with some alcohol. And remember to solder on the correct side, too. That's a mistake people always seem to forget. Don't solder on the component side, unless it's a through-hole board and it's a double-sided. So if it's double-sided through-hole, then you'll need to. If it's surface mount, different story. Usually a surface mount, you're just soldering on top, and that usually requires some hot air. So just give you some information on that. So, all right. So what I want to do is I'm going to go ahead and solder some pieces on here, and then we're going to see how things go. So first thing I'm going to do is to make sure my iron is nice and toasty warm. And I like to do is move things around a little bit, and I know it's getting a little bouncy here, but I'm trying to move things around a little bit so it's easier for me to solder. So, okay, so my iron goes on one side and my solder goes on the other. And I'm going to make sure that this is nice and toasty warm. It is, because I put it on the sponge. And then I'm going to go and give it a quick boom, just like that. A little bit more on it, just a teeny bit more. Reflow. Well, you couldn't see which one I just did. So let me try that again with this one down here. Yeah, that was a mistake. Okay, here we go. So clean my sponge, just clean it off. I like to clean each time and then just give it a quick tin on the iron. And then I just go for it. And I'm trying to be as quick as I can here. I don't have a good angle, by the way. There we go. Perfect. Sometimes finding the right angle is the key. Just a little solder, just like that. Not too much. Let's do this LED right here. Actually, let's do these LEDs right here. And LEDs have thicker, so for a thicker wire, I like to kick the temperature up just a tad bit. Again, I'm going to make sure my iron is nice and toasty warm. And it stopped blinking, so I'm ready to go. So again, I'm going to put it on that side. Count 1001, 1002, 1003. Solder, boom, just like that. 1001, 1002, 1003, boom, just like that. Just like that. There you go. And I do got some excess solder on the leads and stuff, but it looks pretty good. Let's see if I can bring that in a little. This is the IC socket I have, so I'm just going to do a few of these. And again, I'm going to make sure my iron is nice and is warmed up, nice and toasty. I'm going to make sure it's soldered. There's tinning on my thing. It's nice and shiny. And I'm going to clean up my thing a little bit here, and then I'm going to go ahead and solder it up. I'll just put a little bit more on there. So I'm going to start with this top one. And I'm going to go straight through. A lot of times you have on the other side, and I'll show you this in a second, that we have to make sure we have, because this is a double-sided board. And I'm not getting this one. There we go. Get a little bit of flow going. That's a little long, but that's okay. You don't want it too long because it could pop the trace off the board. It could eye a hole out of the board, so I might have to increase the temperature a little bit. That looks okay. Remember, these are eye holes, so it has to heat up everything on there. So there's a lot of surface area that needs to heat it up. A lot of times what we have is solder that does not go through. This is a double-sided board, and this is called through hole. Now, if you notice that the solder has to go through these holes, these are pretty good holes right here. This one right here, it could use a little bit more, but that's okay. But if you notice that if we don't get these components, let me go to the diode here. If we don't get solder to go through all the way through this, and there's a trace on this side right here, then there's not going to be a single. This is a good example. This actually, this trace right here actually goes right to this diode right here. So when I solder this, I have to make sure solder goes all the way through here. So let's just do this diode right here, and let's see if actually we soldered it through. I don't know if we did. No, we did. This was soldered, but it did not go all the way through. So this is a good example of one. So what I'm going to do is I'm going to give it a cleanup on this side only. And it just gave it a little solder. Now the trick here is that if you had to pull these components out on double-sided boards, it could become very difficult. The way to do that is to cut the lead out, add some heat to the lead with a pair of pliers, and try to yank it out. A good tool is this helping hand. Let's see what else. This thing looks good. My LED isn't good, so everything else looks good. So the last step on this is actually to test them once I solder all the components in. Thank you. If you have any questions on this circuit and how to solder, and I'll probably do a few more soldering practices, videos, and stuff like that as I continue to make these boards. But if you have any questions, please feel free to reach to me, and I'll be more than willing to answer your questions, and we'll see if we get this thing up and running. Thank you.